Good morning. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. I'm your host, Leon Jones. And in this segment, I want to talk to you about temperature. And the reason why I want to talk to you about temperature, because a number of scientific items that we talk about today, such as weather and cooking, use temperature. Now, before I get on to temperature, the title of this video is You Need to Know About Temperature. That's right. You need to know about temperature. So before we get into the meat of this discussion, let's define what temperature really is. Now, when we talk about temperature, temperature is the physical property that quantitatively expresses hot and cold. It is the manifestation of thermal energy present in all matter, which is the source of the occurrence of heat, a flow of energy when a body is in contact with another that is colder. Temperature is measured with a thermometer. Thermometers are calibrated in various temperature scales that historically have used various reference points and thermometric substances for definition. The most common scales are the Celsius scale, formerly known as the centigrade scale, and if you are donating the nomenclature, you have a C after the temperature. And you also have the Fahrenheit scale. Now, you have two other scales as well. Because when we deal with absolute zero, we deal with Kelvin and we deal with Rankine. Now, Kelvin is the Celsius scale minus 273 degrees. So you use Kelvin with the centigrade or Celsius scale. And you use your Rankine scale, which is minus 459, or we call it 460, with the Fahrenheit scale. Now, again, when I talk about zero, the lowest theoretical temperature is absolute zero. And that's at which no more thermal energy can be extracted from a body. Experimentally, it can be approached very closely but not reached, which is recognized in the third law of thermodynamics. Now, temperature is very important because temperature is involved in science. And sciences include physics, chemistry, earth science, medicine, biology, ecology, and geography, as well as aspects of daily life. Now, when we talk about temperature, temperature has effects. Now, many physical processes that are related to temperature come from physical properties of materials, including phase. And in the phase, we talk about solid, liquid, gases or gaseous, plasma. Then we deal with density, solubility, vapor pressure, and electrical conductivity. The rate and extent to which chemical reactions occur, the amount of properties of thermal radiation emitted from the surface of an object, or the speed of sound, which is a function of the square root of the absolute temperature. Now, again, I'm going to get into the scales because scales differ in two different ways. The point chosen is 0 degrees and the magnitudes of incremental units or degrees on a scale. Now, again, I just gave you the overview of some of the scales that are used. So the commonly used scales are, again, the Celsius scale is common for most temperature measurements around the world except for the United States. It is an imperial scale that was developed by a historical progress which is led to its point, 0 degrees Celsius, being defined by the freezing point of water, and additional degrees defined so that 100 degrees Celsius was the boiling point of water, both at sea level atmospheric pressure. Because of the 100-degree interval, it was called the centigrade scale. Now, since the standardization of the Kelvin in the International System of Units has subsequently been redefined in the terms of equivalent fixing points on the Kelvin scale, so that the temperature increment of 1 degree Celsius is the same as an increment of 1 Kelvin, though they differ by an additive offset of approximately 273.15 degrees. Now again, the United States commonly uses the Fahrenheit scale, on which freezes at 32 degrees Fahrenheit and it boils at 212 degrees Fahrenheit at sea level atmospheric pressure. Now, again, I just told you about absolute zero. Now, at the absolute zero of temperature, no more energy can be removed from matter as heat, a fact expressed in the third law of thermodynamics. At this temperature, matter contains no macroscopic thermal energy, but still has a quantum mechanical 0-point energy as predicted by the uncertainty principle. Now, this does not enter into the definition of absolute temperature. Experimentally, the absolute zero only can be approached very closely, but never actually reached. So if it were possible to cool a system to absolute zero, all classical motion of its particles would cease and they would be at complete rest in this classical sense. So the absolute zero is defined as 0 degrees Kelvin and is approximately equal to minus 273.15 degrees Celsius or minus 459.67 degrees Rankine. Now you have absolute scales, and some of the absolute scales are referring to the Boltzmann constant or to the Maxwell-Boltzmann distribution and to the Boltzmann statistical mechanical definition of entropy as distinct from the Gibbs definition for independently moving microscopic particles, disregarding interparticle potential energy by, of course, international agreement, which a temperature scale is defined and said to be absolute because it is independent of the characteristics of particular thermometric substances and thermometer mechanisms. Now again, when it comes to temperature, one must understand that temperature is a measurement. Temperature has units. Again, we talk about Kelvin, Rankine, Fahrenheit. We talk about Celsius. But what we have to understand when it comes to temperature, temperature is a physical property of matter that quantitatively expresses hot and cold. It is the manifestation of thermal energy present in all matter, which is the source of occurrence of heat, a flow of energy, when a body is in contact with another. Now, some areas that you use temperature in, talk about HVAC, heating, ventilation, air conditioning, refrigeration, weather. You also deal with dew point. You deal with cooking. You deal with earth science, geography. You even deal with geology. You deal with medicine. But temperature is very important because without temperature, we could not measure the degrees of hot and cold. And of course, basically, there are two different temperature scales, Fahrenheit and Celsius. Celsius is commonly used across the world because it's an international system, like metric, whereas the Fahrenheit system is used here in America. Now, how do you get the Fahrenheit and Celsius? Well, when we talk about 0 degrees Celsius and 100 degrees Fahrenheit, a correction, 0 degrees Celsius and 100 degrees Celsius. Well, the graduations or the increments of a thermometer are divided from 0 to 100 degrees. So that means you go up 100 increments. Now, when you go from the Fahrenheit scale, because we know 0 degrees Celsius is 32 degrees Fahrenheit, and we know that 100 degrees Celsius is 212 degrees Fahrenheit, which 212 degrees is boiling, where 32 degrees is freezing. Well, you go from 32 to 212, you're going up 180 increments. So when you see a thermometer that has Fahrenheit and Celsius, you can look at the increments and you can count them. Now, there are also different conversion factors that you can go from one temperature to the other. But what I'm giving you today is an overall perspective of the importance of temperature. And that concludes this session on temperature from the Mind of STEM channel. And on this channel, you get a daily dose of science, technology, engineering, and math. Please like the video, share the video, and subscribe to this channel, very educational channel. And if you're looking for more controversial content, check me out on the 401 Talk Zone radio show, also here on YouTube and Blog Talk Radio. Now, if you cannot find me on YouTube or Blog Talk Radio, simply go to my Facebook and Twitter pages. Once again, I thank you for listening to this discussion on temperature. Till next time, my name is Leon Jones. Please have a wonderful and gracious day.